Alright, now let's look at the inclined plane problem. So this is our incline, and this is now a rough surface. You have a block on there, and it's free to slide down. So it's sliding down, which means the kinetic friction force is going to point up, right, Fk, and then the usual suspects is going to be Fn, and there's going to be Mg. So now let's first draw a free body diagram. Mg vertically down, Fn normal to the surface, perpendicular to the surface, Fk along the surface. This is all there is. This is the free body diagram for this situation. But now what's important is how to choose our coordinate system. Now since this object is sliding downwards, acceleration is downwards, we should choose x to be pointing down the slope, and thus y will be perpendicular to the slope. So this is our coordinate system. So let's draw our coordinate system here. Again, you realize that mg is neither along x nor along y. So now you need to resolve mg along x and y. So again, the question arises, what angle is theta? So you're given that this is theta, and you are supposed to realize in this case which angle is theta. So now I'm going to tell you what angle is theta, but make sure you understand how to find out which angle is theta. Alright, so this angle is theta, and now you complete these triangles. The mg is the hypotenuse, and now you have to find out what these components are. The x component is going to be mg sine theta. The y component is going to be mg cosine theta. So now mg is resolved along x and y, and now you can start working on your Newton's second law. Sum of all forces in the x direction. Towards positive x, it's mg sine theta. Towards negative x is fk, and that is equal to ma. So we can write fk as sine theta minus mu k fn. That's equal to ma. Do not substitute for fn yet. We do not know what fn is. For that, we need to write the y direction. So the sum of all forces in the y direction plus fn, because fn is along positive y, minus mg cosine theta, because mg cosine theta points in the negative y direction, and that is equal to 0 because there is no acceleration in the y direction, which means Fn, the normal force, is equal to mg cosine theta. So now we plug this into here, and we get mg sine theta minus mu k mg cosine theta is equal to ma. And now we divide both sides by m. The m's disappear, and it leaves us with a is equal to g sine theta minus mu k g cosine theta. So let's take g outside the brackets. Alright, so this is the acceleration in this case. Again, check the units. Sine theta, mu k, cosine theta are unitless. G is acceleration, a is acceleration, so units wise it's fine. Let's look at a special case where mu k is 0. So if there is no friction, then the cosine term disappears, and you're left with a equals g sine theta, which is the answer for inclined plane acceleration in the no friction case. And so if the incline is also 0, the angle theta is 0, then acceleration is going to be 0, so we should confirm that also, and all is good. So make sure you understand what angle is theta again, that's going to be very important, and then work out using the appropriate coordinate system, tilted or rotated coordinate system. Alright, thank you.